What's up, everybody? Welcome back. Today, we're talking about acids and bases, and we are going to be focusing on pH. And as always, you should have looked at this in lecture, so you should have an idea of what a pH, an acid, and base is. But I'm going to start by doing a quick recap. But if you don't understand any of this, make sure that you pause and then go back to your lecture, go back to your book so that you understand it because I want everybody to understand pH. So, before we get into pH, what is an acid or base? An acid, according to Bronsted, is a proton donor, something that gives away its hydrogen. And then a base is a proton acceptor, well, something that accepts protons, right? So an acid gives away a proton, a base accepts proton. By the way, if you remember, a proton is a hydrogen ion, right? So a hydrogen ion, H plus, is a proton, right? So this is the currency when it comes to acids and bases. And I want you to remember this because we are going to revisit this when we come back to pH. So if we take again an acid, right? So acid is, let's say, Ha, right? It gives away its hydrogen. This is how an acid is going to act like. And it does this in water. So Ha plus H2O. So the acid in water is going to give away its hydrogen to water. So it's going to be H3O plus H3O plus A minus. So these are the same equations. It's just that we're showing this that it happens in water, which is important because that's what happens. This one is more accurate. It's a more accurate representation of what happens in water because H plus is not going to be by itself, right? So a base is going to be a proton acceptor. So it accepts protons and then it becomes BH plus. And then same thing if it does happen in water, H2O plus or H2O, then it's going to give us, right? So look at this. When a base is in water, it's not going to give it hydrogen. It's going to get hydrogen from water. So it becomes BH plus. And guess what? We're going to have OH minus. And this, guys, is very important, the OH minus, because we're going to use it to calculate the pH. So a base gives away OH minus, whereas an acid gives away H plus. So we're going to use these to calculate pH. So again, this is an acid, this is a base. This is how they act. And I want you to see something important. H2O here, right? Hydrogen, H2O received hydrogen from acid. And then what is the definition of something that receives the hydrogen? It's a base, right? So here Ha is an acid, water is going to act as a base. But here in the base, right? This is the base, right? Look at what happens to water here. Water now gave away its hydrogen. And what's this thing that gives away its hydrogen? It is an acid. So water can act as an acid or a base. We call this an amphipathic molecule. And it's very important because, again, this will help us when it comes to pH, right? So water has acid base properties and we call it amphiprotic or amphipathic, right? So this is one of the reasons why water is the most commonly used solvent, because it can dissolve acids and bases. It's really cool, right? So water is what we call a universal solvent, right? It can give away hydrogens, it can gain hydrogens, right? It is an acid and can be a base as well. And this gives us something we call the ion product of water. Right? My arrows have shifted a little bit. Yeah, so this is what we call the ion product of water, right? So water can water again, as I say earlier, water can bind, can act as an acid or a base. So H2O. So it's to take H2O plus H2O, right? One is going to give a hydrogen to another. So it's going to be H3O plus OH minus, right? So it's one will be act as an acid, the other one will act as a base. Well, if you calculate the equilibrium of that, right? If you calculate the equilibrium of that, you will find that K, or the equilibrium of water, is going to be equal to the concentration of hydrogen ions times the concentration of OH ions. Why do we care about this a lot? It's because this turns out it doesn't change. In water, it doesn't change. It's always equal to 1 times 10 to the negative 14 times 10 to the negative 14, right? We call this the ion product of water, right? So at 25 degrees Celsius, I want everybody to know this, at 25 degrees Celsius, right? The hydrogen concentration times OH concentration is going to be equal to 1 times 10 to the negative 14. We're going to use this in pH. How are we going to use this? Well, if I give you the concentration of H plus and then I ask you the concentration of OH minus, you can find them by just using this formula, right? So the concentration of OH minus, for example, is going to be equal to 1 times 10 to the negative 14 over the concentration of H plus, right? So if you have H plus concentration, you can find OH minus concentration. If you have OH minus concentration, you can easily find H plus concentration. So make sure that you remember this, because this will come in handy. So this is an example I can give you, like, hey, what is the OH minus concentration of an HCl solution whose hydrogen ion concentration is 1.3 molar, right? So if I give you HCl, right, HCl concentration is going to be, it's 1.3 molar. Look at this. HCl concentration, HCl gives us H plus Cl minus, right? In water. Well, if you have one HCl, 1 mole of HCl, you're going to have 1 mole of H plus, right? So the concentration of HCl is the same as the concentration of H plus concentration. And if you have H plus concentration, guess what? You can get OH minus concentration like we just looked at here, right? Very easy. You can just calculate it, right? So before we do that, then, again, from the H plus concentration, we are going to measure the pH, right? We're going to measure the pH because I am going to just give you a teaser to kind of explain where I'm coming from here. We're going to measure the pH because the pH, right? The pH is equal to negative log of H plus concentration. So if you have the H plus concentration, you're going to put it into this formula, you get the pH. However, this is only for strong acids and bases. For weak acids and bases, this will not be true. So let me explain. Let's talk a little bit about what is the difference between a weak and a strong acid, right? So the main difference between a strong acid and the weak acid and all that stuff is how they dissociate, right? A strong acid is going to dissolves completely in water. A weak acid dissolves partially in water. A strong acid, when it dissolves, is irreversible, right? All of Ha is going to give us H plus plus A minus. But a weak acid is going to be reversible. It can come back, right? And then a strong acid does not reach equilibrium. A weak acid reaches equilibrium because it's going back and forth, right? So big difference. So here an example is HCl, right? That goes away and gives us H plus plus Cl minus. All of HCl dissolves in water to give us H plus. That's why it is irreversible, dissolves completely in no equilibrium. That's a strong acid. But a weak acid like acetic acid, right? Acetic acid is CH3COOH, is going to dissolve in water partially. So it's going to be CH3 COO minus plus H plus, right? But it's going to go back and forth. It's a reversible equation that's going to go back and forth, will never reach completion, right? So it's very important if you see an acid to be able to tell whether or not it is a strong acid or a weak acid. But it's also important for a base as well. So I gave you a table here of weak acid, strong acids, strong bases, because the easiest way to remember this is because we have 5 most common strong acids. Just remember this, right? HBr, HCl, HI, HNO3, HClO4, H2SO4. These are the main 6 acids, the main 6 strong acids. Any other acid will be weak, right? Just like acetic acid, carbonic acid, all of the other acids are weak acids, right? And then strong bases are even easier to remember. Why? Because strong bases will be metal hydroxides, right? If you have a metal and OH group, you have a strong base, right? So you have strong acids, strong bases. Very cool, right? So if you remember the strong acid and strong bases, then everything else is weak. Now, weak bases can be tricky, but the best way to remember them is most weak bases. So the most common weak bases that we use are ammonia and sodium bicarbonate, right? This is baking soda, but also we have other things that have NH group in them as well, right? So if you haven't noticed already, our model strong acid is HCl. We use it a lot. Our model strong base is NaOH. We use it a lot. Our model weak acid is acetic acid. You see it everywhere. And then our model weak base is ammonia, right? So you have access to all of these chemicals. But again, make sure that any chemical that I give you, you'll be able to tell me, is it an acid? Is it a base? Is it strong? Is it weak? Very important. Why is it important? Because the pH is different based on whether or not it's strong. So let's start with the pH of strong acids and bases. The pH, right? The pH is a scale that indicates how acidic something is or how basic something is. It goes from 0 to 14. 0 is very acidic, 14 is very basic, right? And again, the pH is negative log of H3O plus. Remember that H3O plus is the same as H plus ions. So we go back and forth with this. Don't be um, confused. So pH is equal to negative log of H plus. It's the same thing, right? It's just that H plus, when it's in water, is bound to water. That's it. That's the pH. That's the pH of a strong acid, right? So pH has a scale from 0 to 7. If you go from 0 to 7, you have an acid. From 7 to 14, you have a base. And then in the middle is neutral, right? So the pH scale is pretty high. I added this to kind of give you an example and an idea, right? Because like HCl is very acidic, it's at 0, but then sodium hydroxide NaOH is very basic, it's at 14. But in the middle you have water. Blood is at pH 7.4, for example. Coffee is acidic, so at about 5. Tomatoes, lemon juice is at around 2. Stomach acid is very acidic, it's about 1. So you can see kind of where um, acids and different things range from. But one thing that you have to understand, very important, is because we're using log, pH is actually a big difference. Like a pH of 1 is different, is very big, right? Meaning that if you have something that has a pH of 10 and then something that has a pH of 9, it's not like one one more point stronger. No, it's 10 times more acidic, right? So a difference in one pH unit means it's 10 times more acidic or 10 times more basic. That's what we call logarithmic scale. So make sure that you understand that. It's very important. But we measure pH in the lab by using pH meters. We also use pH paper, which you're going to be using in this lab, right? But we also calculate pH. We also calculate pH. So let's look at a few of the formulas that I want you to know when it comes to pH, right? So the first one is like, yes, we have pH, right? We have pH is equal to negative log of H plus. But then you have POH is equal to negative of OH minus. So if you don't have an acid, right? So you have NaOH here, you don't have H plus concentration, right? Because we know that, there's no coming back. We have one arrow, but NaOH becomes Na plus OH minus. So you can get OH minus concentration. If I ask you what is the pH, you can use this formula that we looked at earlier to find the H plus concentration, right? So if you have OH minus concentration, you can find the H plus concentration. Why? Because you can use that H plus concentration to find the pH, right? Another way you can do that is POH, right? If you found the POH from OH minus concentration, you can also use this formula. pH plus POH equals 14. You can use this to find the pH. It's pretty cool, right? So these are formulas of strong acids and bases, right? Strong electrolytes, which are strong acids and bases. So this is an example. If I give you like pH of rainwater contains, this is the pH, and then they're asking the H plus concentration. This is actually a good question that leads me to kind of give you a little formula. So for strong acids and bases, right? For strong acids and bases, right? pH is equal to negative log of H plus. POH is equal to negative log of OH minus, right? And then pH plus POH is equal to 14. And then another one is H plus times OH minus is equal to 10 to the negative 14, right? Pretty cool. And then another one is you can flip this if you want to find H plus is the reverse log, which is H equal to 10 to the negative pH, right? You can use this. Or same here, if you want to find OH minus, concentration from POH is equal to 10 to the negative POH, right? So these are the formulas that we're going to use to calculate the pH for strong acids and bases. So now going to the weak acids and bases, we also need to know how to do this. So the problem with this again is that for acids and bases, these are not going to dissolve fully, right? So if you have a weak acid, it's not going to give all. So not all of the H plus, not all of the H plus that's in here is going to be in here. Not all of it is going to dissolve. It will dissolve partially, and because of that, we're gonna need to know how much, right? Because not all of this will give all of this. So we're going to know how much. And one of the things that we use is what we call the ionization constant, which is the equilibrium constant, right? You know about equilibrium constant. The equilibrium constant of this acid, which is the concentration of H plus times the concentration of A minus over HA, right? This is the ionization constant. So different acids have different ionization constant, and the ionization constant determines how fast or how slow this acid or a base will dissolve, right? So again, you should have this. You should have this in your lecture. So I will not spend too much on this. But if you don't know how to do this, make sure that you review the lecture and then send me a question or connect with me so that I can explain. But in order to find the pH of a weak acid or base, we use what we call an ICE table. ICE table, right? ICE, ICE table. What is ICE? Initial, change, and equilibrium. That is the ICE table, right? So if I give you that if I tell you that I have 0.5 molar of HF solution, and then I ask you what is the pH, pay attention to this, right? If I ask you what is the pH of 0.5 molar of HCl, if it's HCl, you know it's a strong acid, so it's just negative log of H plus, which is negative log of 0.5, because it's HCl. But this is HF. HF is not a strong acid, and because it's not a strong acid, we know that not all of it will dissolve. And it becomes a problem, but it's a problem that you can solve. So you're going to say, okay, we have initial, we have change, we have equilibrium. The initial conditions or initial concentrations of HF is what they gave us, right? We started with 0.5, but then our result, H plus, F minus, we don't have anything, right? And then you have change, the thing that dissolves, the amount that dissolves into H plus. So you're going to remove, right? So HF will lose this change minus X, which is the same as we gain, right? That is the change. And then the equilibrium, it will be, the total, right? This minus the change, or this, the original plus the change. So these will be the K at equilibrium. Why do we want this? Is because we have the equilibrium constant, right? Because the equilibrium constant, Ka, will be the products X times X over this. And look at this, X times X over this is equal to Ka. And guess what? Ka of any acid, we now know the Ka of any acid or a base. So if I gave you the Ka of this acid, you can find X, right? And the easiest way to do this, and again, I go over this way in way more details into the lecture, but the best way to come up with this to actually approximate, if your Ka is pretty small, then we can ignore this number and then make an assumption that 0.5 minus X is equal to around 0.5, right? So the change is so small that 0.5 is good. And that should give us that x squared over 0.5 is equal to Ka, right? X squared over 0.5 is equal to Ka, which is equal to this. And from here, we can find x very quickly. And then after you find x, guess what? This is the H plus. Look at this. X is the H plus concentration at equilibrium, right? So here you find that your X is equal to this, and then the pH is what? pH is going to be equal to, right? The pH is going to be equal to this. It's going to be equal to the 0.5 minus X, right? The 0.5 minus X. No, it's going to be equal, not 0.5 minus X. It's going to be equal to negative log of H plus. pH is negative log of H plus, which is negative log of H plus, which is negative log of X, because X is H plus at equilibrium. Do you see what I mean? Again, if you don't understand this, make sure that you go back to the lecture and you can ask me questions as well, because it's very important that you know. It's very important that you know how to solve, how to find the pH of an acidic solution and a basic solution, whether it's strong, whether it's weak. So now you know that it's very different. It's very different. Like the pH is very different when you have a strong acid, strong base, where you use OH minus, or weak acid or weak base, right? Just like here we have on a weak acid, we have Ka. On a weak base, we're gonna have Kb, right? So make sure that you know how to do that. So this lab is mainly about pH, but it's not just about pH, right? It's going to be that I'm going to give you a few solutions, right? I'm going to give you a few solutions. And in these solutions, we are going to calculate their pH on paper, and then we're going to measure their pH, right? We're going to calculate their pH actually. We're going to calculate their pH, and then after that, we are going to measure their concentration from what their pH is. So we're going to kind of do it the other way. And let me see if I can look at the lab a little bit and see if there's anything that I'll need to tell you. Of course, we're going to be using acids and bases, so make sure that you are safe. But we're going to use color charts for pHs, right? So I'm going to give you pH paper that has numbers, so that you dip your pH paper into your solution. Depending on what color it gives you, you're going to be able to tell me what pH it is. And we're also going to use color indicators as well. So here we're going to use color indicator for pH, and then we're going to use pH paper for pH. And again, here actually I'm going to add concentration. So you're going to measure concentration of what you have based on the pH that you measured. And guess what? We're going to have some stuff like HCl, which is strong acid, and NaOH, which is a strong base. We're even going to have a mixture of them. But things like vinegar, which is acetic acid, is a weak acid. So you have to keep that in mind. Or things like baking soda are a weak base. So we have to keep that in mind. And I'm also going to give you two unknowns so that you can measure their pH and then tell me what they are. The unknowns will be from here, right? So that is the lab, guys. You should understand what you need to do. But of course, if you have questions, make sure that you understand before you get started. But if not, let's get started with the lab.
So this should be a pretty fun lab. You're gonna have a bunch of solutions, and all you're gonna do for this lab is calculate their pH and then measure their pH two ways and then average the pH. So it should be fun because it should be pretty colorful, and we're gonna use some of at-home ingredients, even though they are going to be supplied to you. So you should have first your goggles and gloves as always, and on top of that you're gonna have solutions that you are given. So in those solutions, make sure that you have everything on this table, right? So you're gonna have distilled water, hydrochloric acid, NaOH, vinegar or acetic acid, baking soda, and then you should make a mixture. Some of you might have a mixture already made, but if it's not made, make a mixture of equal parts of HCl and NaOH. And you should also have an unknown compound that you will measure the pH of to tell if it's acid or base. On the second column, you see the predicted pH. So based on what you learned about pH, you should be able to tell me what the pH of HCl is, pH of water, pH of NaOH, even pH of vinegar and baking soda. Keeping in mind that vinegar and baking soda are a weak acid and weak base respectively. So make sure that you can predict that accordingly, because we learned that to find the pH of weak acids and bases is different from finding the pH of strong acids and bases. You can even predict the pH of the mixture of HCl and NaOH based on what we learned about acid base reactions and titrations, right? You can't predict the unknown yet, but again, after that you should be ready to get started. And again, to get started, you should have your goggles and gloves, and on top of that you have all of the solutions that are required. Have a test tubes for all of the solutions, and a test tube rack to put them in. You should have a star bar or something to mix your reactions with. You should have a cylinder, right? You should be able to have a cylinder so that you can measure. You should have your pipettes to be able to dispense your solution, right? And then on top of that, very importantly, you should have a pH paper and a universal indicator, and both of them will give you pH by changing color. So you should also have a color key, so that if you see a color in your solution or on your paper, you're gonna be able to tell what pH it is. So after you set it up together, after you put on your goggles and gloves, right, as demonstrated here, put on your goggles and gloves, right, make sure that you're good to go. And then after that, you set up your test tubes, label your test tubes the same thing as your solutions so that you keep track of everything, right? And this should be the same as what you have on your table as well. Same orders, same labels, and same labels as the original solutions. And after you label them, you can start with the first experiment. And the first experiment is going to be measuring pH based on pH paper, right? But before you do that, of course, you're going to add your solutions, right? Now, we can measure the solution, but for this one, we really don't have to measure the solution. I just want you to add 3 milliliters into a test tube so that we're able to reach it with your pH paper. So you can either measure it in your cylinder, but you can even pour it in your test tube. It doesn't have to be exact, as long as your pH meter can reach in. So you're going to pour all your solutions in the test tubes, and then after you pour all your solutions in the test tube, you're gonna be ready to measure their pH. And the first way to measure the pH is going to be using a pH paper, right? So skipping back to the pH paper, we're just going to look at to put in your pH paper. Here Alex is making sure that we have all the liquid we need, but again, after that, we're going to measure the pH paper. So, and all you do is you put in your pH paper. That's why we added more so that we can reach it, because the pH paper is kind of short. So if you have something to hold your pH paper so that it can reach inside, you can put less liquid. But if you can't reach, you might have to add more liquid. But after that, you add the pH paper, you look at the color, and then you look at the color code in your pH, as Alex is doing here, and then it's gonna give you a pH number. And then guess what, you just put it on your notebook after that, right? So that should be easy. And again, we do the same for all of them, and that is the pH paper. pH paper is very good at recording pH. But since pH paper is not very precise, we're gonna use another technique that's actually really cool. You should be able to enjoy this. And this technique is indicator, universal indicator. So instead of using pH paper, we're going to add a few drops of indicator, right? We're going to add a few drops of your indicator into each solution, and whatever color they give you will give the pH. So I really like the indicator because it makes all your solution very colorful, and you have many different colors, and different colors represent different pHs. So you're gonna have to determine which one is better at determining pH, or which one you like more. But again, how do we determine which one is better? We're going to determine which one is better by comparing it to our predicted, right? So you have your predicted pH, and then you have the indicator color pH, and then pH paper pH, and then you're going to also average them to see their pH. So that is basically what we're going to be doing. We are going to be measuring our pH using pH paper as shown here. We're going to be recording it, and then after we do everything, right, just take time to admire these beautiful colors, and make sure that they're accurate. But again, we also have fun. And then after that, you can just clean up. And for these ones, it's very easy to just go ahead and dump them into the sink. After you dump them into the sink, clean your test tubes with water, and then after that, you are done. You can clean up your bench, store your test tubes because we're gonna need them. You can just throw them away. You can then recycle any chemicals that we haven't used. But other than that, that is your lab. That should be enough for today's lab.
All right, guys, that was the pH of acids and bases. I hope by the end of this lab, you not only know how to measure pH, but to calculate it. And I hope it was fun. I hope you understand a little bit about the acidity and basicity of the things around your house, and you'll be able to explain you'll be able to explain it to somebody who hasn't taken chemistry yet. But other than that, I will see you in the next lab. Bye bye.